Everyone's heard of Huntington's disease, but not everyone understands the mechanism behind it. Today we are going to talk you through what's included in the motor loop, how it responds with and without cortical input, as well as how Huntington's disease interferes with its normal function to cause hyperkinesia and akinesia. Taking a coronal slice of the brain, we can see the caudate and putamen nuclei, collectively known as the dorsal striatum, as well as the globus pallidus and the ventrolateral complex of the thalamus, often abbreviated as the VLO. This is what forms the motor loop. With no initiating cortical input coming from the prefrontal cortex, the dorsal striatum tonically, meaning continuously, activates the globus pallidus. The tonic activation of the globus pallidus means it's able to tonically inhibit the VLO. Therefore, there's no signal sent from the VLO to the premotor area, often abbreviated as Brodmann area 6, hence there's no initiation of movement. With cortical input, the dorsal striatum inhibits the globus pallidus. This means that the globus pallidus is no longer able to carry out its tonic inhibition of the VLO, essentially releasing the VLO to activate the premotor area and hence initiate movement. Now let's consider when the initiating motor loop goes haywire in Huntington's disease. For some quick background, Huntington's disease is an autosomal dominant mutation affecting a protein creatively named Huntingtin. The mutation expands the CAG repeats in the coding sequence for Huntington. This results in an increased polyglutamine tract, which, when more than 36 residues long, becomes toxic to neurons, causing the degeneration of the striatum. The loss of the striatum leads to an increase in the lateral ventricle's volume. With a decrease in dorsal striatum's activation of the globus pallidus becomes less and less effective in carrying out its tonic inhibition of the VLO. Therefore, the VLO, over time, is able to increase its activity towards the premotor area and initiate movement without the requirement of cortical input. The implications of this are severe. As you can probably guess, if there's an initiation of movement without cortical input from the prefrontal cortex, it essentially results in rapid and jerky movements known as hyperkinesia. This is where the chorea part of Huntington's chorea comes from. Chorea is defined as a neurological disorder characterized by rapid and involuntary movements affecting especially the shoulders, hips and face. Chorea is a defining symptom of early stage Huntington's disease. However, a symptom that appears later onwards is akinesia, an overall decrease in movement. To understand how this symptom occurs, you have to also realize that another function of the dorsal striatum is to inhibit the activity of the globus pallidus with the arrival of cortical input from the prefrontal cortex. And so, with the dorsal striatum essentially non-functional, the globus pallidus is able to carry out its tonic inhibition of the VLO, inhibiting the initiation of movement even if there's incoming cortical input. This may sound counterintuitive. How can the same disease have an early symptom of hyperkinesia only to later have akinesia? This can be explained by the simple fact that Huntington's disease is a progressive disease. Consider the initial symptom of hyperkinesia may be caused by the loss of the striatum directly responsible for the tonic activation of the globus pallidus. But later on, there's also a loss of the striatum responsible for the inhibition of the globus pallidus if there's cortical input. This is what causes the akinesia.